In a previous example, we looked at how to add an element to a set, as well as including a second set into a first set. Well, what happens if we didn't want to modify our original sets? Well, the union operator, or the union method, allows us to add a set to the first set, but it creates a third set for us. This way, we're not modifying our original sets. And this is very similar to a mathematical union. As I see here, I have some examples. And when I run this, I see set 1, set 2, and then I see set 3. Set 3 came out of the union of set 1 and set 2. Now, if there were duplicate items in set 1 and set 2, they would not be shown. And let's take a look at that real quick. Notice in the example, we have some set items which are duplicated between our set 1 and set 2. When we run this, our set is put together. However, any duplicated item, as we mentioned before, is not included with our set. Well, a lot of times in mathematics, we don't write union, we use a single vertical line. And Python allows us to do this as well. We use the pipe operator, which on a US-style keyboard is located just above the enter key. And it's the same thing as saying set1 dot union set2. It's just a little bit faster and easier. When we run this, you'll notice that set 1 and set 2 are unmodified, just as when we used the .union method. And set 3 is a combination of those two. So it's an identical way of doing the union method. Another common thing that we'll do with sets is we'll find the intersection. The intersection is where are there overlapping values that are the same between two sets. The intersection method, just like with the union method, creates a new set with those results. So set 1 and set 2 are left alone. When we run this, we see that we have our original set 1 and set 2, and only the items which are in both set 1 and set 2 show up in set 3. So set 1.difference and passing in set 2 says find all my elements that are in set 1 that are not in set 2. Symmetric difference says I want to find all of my unique elements between both sets. Whatever is unique in set 1, add that to my set, as well as whatever is unique to set 2. So I should have potentially more items whenever I use symmetric difference than if I use difference. When I run this script, I'll notice that set 3, which used the difference method, only had elements 1 and 2. They're the only elements that were unique to set 1. But set 4, which contained the symmetric difference of set 1 and set 2, has elements 1, 2, 6, and 7. Because 6 and 7 come from set 2 and were not in set 1. A common thing that we need to do when working with sets is to determine if there's a superset or a subset. Python gives us both is subset and is superset, and they return Boolean values. So in our first example on line 4, we see that set2.isSubset set1. And this is just seeing if set 2 is a subset of set 1. It's an easy way to say that logically. To be a subset, it means that all of my elements in my set have to belong to the other set. I cannot have any elements that are not in it. A superset says that all the elements in the subset have to belong to me, and I may have others. So I have a couple of simple print statements, and they should return a Boolean value. If I test these out, set 2 is a subset of set 1, so it returns true. That means logically, of course, that set 1 is a superset of set 2, and so it also shows 2. And just to verify, set 2, which being a subset cannot be a superset of set 1, is returning false, just as we expected. So anytime you work with mathematical sets in a programming environment, this is a common thing that you'll be running into, whether it's for unions, intersections, or determining subsets and supersets. And so these are just some of the tools that Python gives you to work with sets a little bit easier.